Welcome back to another explainer. Today, we're taking a tour of a digital factory. Imagine a totally chaotic world of raw data, clicks, sales, user behavior, sensor logs, just flying around everywhere. How do businesses actually use this stuff? Well, they use an invisible, highly efficient assembly line to transform all that chaos into pristine, structured business value. That's right, today we're diving into ETL pipelines, the absolute roadmap for a data engineer. Now, before we get too deep into the actual machinery, I want to anchor our discussion with a really fantastic reminder straight from our source material today. Everyone learns uniquely. Treat this as direction, not a fixed rulebook. The world of data engineering is vast, and it's constantly evolving. We're going to look at some incredible tools and frameworks today, but remember, real growth, it comes from hands-on practice. You really have to roll up your sleeves and solve real-world problems to truly master this. So here's our literal roadmap for today. We've got 6 main pit stops: navigating the data roadmap, the core of ETL, inside the architecture layers, the data engineer toolkit, real-world business impact, and finally, best practices for success. Okay, let's dive right into this. Section 1, navigating the data roadmap. So you might be wondering, why is data engineering infrastructure so universally critical in modern business? We hear a ton of buzzwords out there, right? AI, machine learning, advanced analytics. But here's the secret. Literally, none of that magic happens without the foundational plumbing. ETL pipelines are that plumbing. You simply cannot train a reliable machine learning model or run seamless daily operations if the data feeding those systems is just a messy, unorganized swamp. ETL makes the data usable. It's the absolutely critical first step before any of that high-level analytics can actually happen. Let's transition to the digital assembly line itself. Section 2, the core of ETL. So how does this plumbing actually work in practice? Let's unpack this famous 3-letter acronym. This is the heart of the factory floor. Step 1 is extract. This is where we gather raw data from a bunch of different sources. Maybe it's a mobile app, a customer database, or an external API. Step 2 is transform. Now this is the heavy lifting. The raw data is messy, so we rigorously refine it. We clean it up, standardize the formats, and enrich it by combining different data streams together. And finally, step 3 is load, where we store this newly refined, pristine data into a centralized data warehouse or data lake, where it's finally ready to be analyzed. Now, there's been a pretty massive shift recently in how modern teams operate. Traditionally, we did ETL, extract, then transform that data before loading it into the final warehouse, mostly because storage and computing used to be really expensive. But today, with these incredibly powerful cloud data warehouses, we often see ELT, extract, load the raw data directly into the warehouse, and then transform it using the warehouse's immense computing power. It's a subtle switch in the acronym, but it's a massive shift in architecture that our source notes as a much simpler, modern approach. We also have to decide when this factory actually runs. On one hand, we've got batch pipelines. These process data in large, scheduled chunks, say every night at 2 a.m. It's efficient, it's reliable, and it's great for historical reporting. But on the flip side, we have real-time pipelines. These deal with continuous, live streaming data. Think of fraud detection on a credit card swipe. That simply cannot wait until 2 a.m., right? Real-time is incredibly powerful, but it definitely comes with inherent challenges when it comes to complexity and maintenance. Let's shift over to the factory floor layout. Section 3. Inside the architecture layers. Let's zoom out a bit and look at the actual blueprint of the factory. If you follow the hero's journey of a single data point on this timeline, it begins at point 1, the chaotic, unorganized sources. From there, it moves into point 2, a staging area. Kind of think of this as the loading dock, where everything is just gathered temporarily. Then, at point 3, the crucial transformation occurs, cleaning and shaping all that raw material. Point 4 is the warehouse. These are the organized, well-lit shelves where the polished data sits securely. And finally, point 5 is consumption, where business analysts and data scientists actually access the data to make their decisions. It's a brilliant, highly logical progression. And this brings us to the really exciting stuff. Section 4, the Data Engineer Toolkit. A master craftsman is nothing without their tools. And this brilliantly illustrates that when we look at the modern data stack, it really helps to categorize these heavy-hitting brands by their exact pipeline function. For ingestion, gathering the data, we use tools like Kafka, Fivetran, or Glue. For transformation, we rely on powerhouses like Spark, dbt, or Pandas. Then, for storage, we're looking at industry giants like Snowflake, BigQuery, or S3. Of course, we need a conductor for this whole orchestra, right? That's orchestration, handled by Airflow or Prefect. And finally, monitoring with tools like Great Expectations or Monte Carlo to ensure pristine quality. Once you understand what function a tool serves, the whole tech stack suddenly makes perfect sense. Let's pivot from the abstract tools to the ultimate final product. Section 5, Real-World Business Impact. So what's the so what here? Why do we build all of this abstract tooling? Well, it's because we actually interact with the results of ETL pipelines every single day. Look at Walmart. They rely on massive data pipelines to generate daily sales reporting, ensuring that every single store knows exactly what sold yesterday. Or look at Amazon. You know that hyper-specific customer personalization recommending exactly what you want to buy next? That is fueled by highly complex data pipelines. And Target uses these exact systems for inventory optimization, making sure that when you walk in, the items you need are literally right there on the shelves. This invisible tech creates incredibly tangible, everyday consumer experiences. Let's head to our final pit stop, Section 6, Best Practices for Success. Building this massive factory is one thing, but keeping it running smoothly is a whole other ballgame. The source outlines some absolutely essential maintenance strategies for master architects. First up, utilizing modular design and embracing that modern ELT approach in powerful cloud warehouses that we discussed earlier. Second, and I literally cannot stress this enough, automated data quality checks. You absolutely need the system to automatically alert you if bad data enters the pipeline, way before it ruins a crucial business report. Next, you've got to plan for schema evolution, because your source data formats will inevitably change over time, and you need continuous monitoring alongside that. And finally, designing for scalability. Your data volume is going to grow, and your pipeline must be able to handle that growth seamlessly to ensure long-term business value. So we've mapped out the entire journey from raw, messy sources all the way to pristine, actionable business intelligence. We've seen the tools, the architecture layers, and the massive real-world impact. So I want to leave you with a thought. With the ultimate data pipeline at your fingertips, what insights will you build? Take this roadmap, roll up your sleeves, and start solving your own real-world problems. Thanks for joining me on this explainer. I hope you found it as fascinating as I did, and keep learning.